Hi everyone, today we will talk about a critical production issue, in-flight transactions. User clicks buy now, charge $299, inventory reserved, then suddenly pod restarts. Order confirmation never sent, email never sent, shipment never created, money taken, no order, customer furious. This is the in-flight transaction problem. An in-flight transaction is any multi-step process that spans time. Let's say step 1, charge the credit card, reserve inventory, create the order record, send confirmation email, trigger shipment workflow. In a monolith with database transactions, this is atomic, all or nothing. But in microservices with Kubernetes, each step calls a different service. Each step takes time. Pods can restart between any step. Payment service success. Pod dies. Email service never reached. The transaction is partial and partial is worse than failed. Here's what makes this brutal. Let's take a scenario of order processing microservice. Step 1, call payment API. Stripe charges card, $299 captured. Step 2, call inventory service, reserve 1 unit, stock decremented. Step 3, write to orders DB, start transaction. Here pod gets out of memory killed mid transaction. Kubernetes restarts the pod, fresh memory, no state. But Stripe, they have the $299 captured earlier. Inventory was decremented earlier. The pod doesn't remember this. The request is gone. Now, retry the entire transaction. You will double charge the customer. Do nothing. Customer paid. Never gets the order. Manual investigation. This happens every pod restart, multiple times a day. And you won't know until customer starts complaining about their orders not getting delivered. Now comes the important part. Why do these pods restart? Sometimes out of memory killed, memory limit exceeded, immediate termination, CPU throttling, pod becomes unhealthy, restart. Deployment. When you have rolling updates, old pods gets deleted. Node eviction, node pressure, pods redistributed. Liveness probe failure, pod stuck, kubelet kills it. Average Kubernetes cluster pod restart 10 to 15 times a day. Average transaction duration 2 to 5 seconds. You are in flight window. Thousands of transactions per day at risk. And here's the kicker. Kubernetes gave you 30 seconds graceful shutdown. But if your transaction takes 5 seconds and you have 100 congruent requests, only 6 will finish, the rest gets terminated. Now comes the solution. Solution 1. We have to make every step idempotent with transaction IDs. Before calling Stripe, generate a unique transaction ID and post this to the charge API with this idempotency key. If the pod dies and retries, Stripe sees the same key, returns the original charge, no double billing. Same for inventory. Send this idempotency key to the reserve API. Inventory service checks already reserved for this transaction, return success. Every external call idempotent. Pod restarts, safe to retry the entire flow. The catch here is every request must support idempotency, and you need distributed state to track what's being done. This is table stakes, but it is not enough. Solution 2. Saga Pattern. Saga Pattern with compensation. Each step publishes an event. A coordinator tracks progress. Step 1. Charge payment. Event payment created. Step 2. Reserve inventory. New event gets created. Inventory reserved. Step 3. Create order. New event gets created. Order created. Pod dies at step 3. Coordinator sees this, Payment completed? Yes. Inventory reserved? Yes. Order created? No. It triggers compensation. Refund payment, release inventory. Transaction gets rolled back. Customer is not charged for nothing. This is choreography saga with event sourcing. Every step is recorded. Every step can be undone. If pod restarts, coordinator resumes from the last event. The downside here is complexity. You need an extra event bus, a coordinator, and a compensation logic for every step. But it's worth it. Here comes the last solution, Outbox Pattern. Don't call external services directly. Write a local outbox table in the same transaction. Let's say we begin a transaction and we insert records into order table. At the same time, we'll insert into an outbox table with an event payload. Let's say we come to the commit state. Both succeed or both fail, atomic. A background worker reads the outbox and publishes events. Pod dies mid transaction, either transaction committed, event is in outbox, worker will publish it, or transaction rolled back, nothing in outbox, safe to retry. No in-flight state, no partial completion, combined with idempotency. This is how Uber, Netflix, Airbnb handle it. In distributed systems, there is no such thing as a simple transaction. Production setup. Always have idempotency keys on every external API call. Outbox pattern for critical state changes. Saga coordinator for complex workflows. Graceful shutdown hooks to finish in-flight work. Monitoring for stuck transactions. Dead letter queues for failures. When a pod restarts, your architecture handles it, not your customers. Because in production, pods die. That's not a bug, that's Kubernetes. Thank you. Stay tuned for more production issues.